Continuing on with these half-angle formulas, in this example here, which I don't think is labeled in your copy, so please make sure you have these in your notes. We have this triangle here, and this angle here is going to represent our alpha, and this side here is 8, and this is 15. So please make sure you label in your notes so you know where I'm getting these numbers from. So there's two things we're going to do. First thing is we're going to find the sine of this alpha over 2. Different from the other examples we did. In the other examples, we were given specific angles, either in degrees or radian measure, but we had angles that we used to find the trig functions for our formula. In this example, we don't know alpha. We're never going to know alpha, but that's okay. We can still get the trig functions that we need. So I've written the formula down here so you don't have to look at the back of my hand so much. Sine of alpha over 2, or an angle divided by 2, is plus minus the square root of 1 minus the cosine of alpha over 2. So all of that is under the square root symbol. So we can see here we need to know the cosine of our alpha. And we don't have that information. All we have is this triangle, which we can see even the triangle is missing some necessary information. So to find cosine, it's the adjacent over the hypotenuse, and we don't know the hypotenuse yet. So this hypotenuse, we're going to use Pythagorean theorem, 8 squared plus 15 squared is equal to, I'll call it h, or h squared. So here we have 8 squared is 64, 15 squared is 225, 64 and 225. We have 289 is equal to h squared. And so our hypotenuse is going to be equal to the square root of 289, which happens to be nice square. 289, nice square number, so it's 17. So we don't have to mess around with any radicals, at least not yet. So there is our hypotenuse. And so now we know that we need the cosine of this alpha. So the cosine of alpha is the adjacent over hypotenuse, which is going to be 15 over 17. So there we have our cosine. So we can come here to our formula and we can make our substitutions. And so here we have, this would be equal to square root 1 minus 15 over 17, and all of this is over 2. I want to make sure you see that that 2 is under the square root symbol. Now, in this particular problem, this is a triangle. So we're going to assume that it's in the first quadrant because we're not given any other information. So our cosine is going to be positive. Now we have to make this similar judgment call here, this plus minus. Which one do we use for our answer? Again, being that we have a picture of a triangle, we make the assumption it's in Q1, and so therefore our sign is also going to be positive. I'm not going to, well, maybe I will, just so you know, it's not that I forgot the sign, it is going to be positive. So here's our information, and now I'm sure that you can see we're going to have to clean this up. So we could subtract 1 minus 15 over 17, get a fraction, and then clean it up. I'm going to just do what I always do and clean up the complex fraction, multiplying by the least common denominator. So here, this would be over 1, this would be over 1, so our denominator is 1, 1, 17. The LCD would be 17. So we're going to multiply everything by 17. And so 1 times 17, so here is our square root symbol. So this is 17. These 17s cancel out. minus 15, and 2 times 17 in the denominator is 34. So continuing on, 17 minus 15, that's 2 over 34. Still everything is under the square root. Continuing on over here, 2 over 34, we have a fraction. So that would be 1 over 17. 2 divided by 2 is 1. 34 divided by 2 is 17. So here is our answer. We have this 17 in the denominator. We need to rationalize. So what I'm going to do here, in case it is helpful for you to see it like this, I'm going to break this up into the square root 1 over the square root 17. So you can see that that 17 needs to be dealt with because it's under the radical. Multiplying numerator and denominator by the square root of 17, and we get a 17 in the denominator, and now in the numerator we have square root of 17. I just realized here, this was silliness on my part because the square root of 1 is just 1. So I'm going to get rid of that square root symbol because it's not necessary. So it doesn't affect my answer, but just I thought that looked silly there because the square root of 1 is just 1. So our answer would be square root 17 over 17. Now the last one in this half angle formulas, we're going to look at the tangent of a half angle. So for this particular example, I'm going to use the formula that the tangent of alpha over 2 is equal to the sine of alpha over 1 plus the cosine of alpha. Different than the one I used in the other example. As I said, you can use any. I'm going to use this one just to show you what another one would look like. So when we take a look at this formula, we can see we need the sine of alpha. We don't have that yet. We'll have to find that. But in the denominator, we have 1 plus the cosine of alpha, and that we know. We know that the cosine of alpha is our 15 over 17. So let me put that in now, 15 over 17. So we have that information in the denominator, and let's come back up here to take a look at what our sine would be. The sine of alpha is the opposite over the hypotenuse. In this example, the opposite is 8, and our hypotenuse is the 17. So our sine would be 8 over 17, and again, we're assuming that it's in Q1 since all we have is this triangle picture. So back here, sine of alpha, this is going to be our 8 over 17. And once again, we have this complex fraction that we're going to have to deal with to clean up. And 17, 17, and this is a whole number 1, no denominator. 17 is going to be the LCD that we're going to multiply everything by in order to get this to be in a more simple form, in the simpler form. So these 17s cancel, this 17 cancel, nothing cancels here because the denominator is 1, or think of it as a whole number. And then here, what's left? The 17s are gone, so we have 8 in the numerator. And in the denominator, we have 17 times 1, which is 17. And then we have 15. And then we can add 17 and 15. This is 32. And now 8 over 32 simplifies to 1 over 4. And that would be our answer. We don't have to worry about the signs because assuming it's the picture, everything is in quadrant 1. We haven't been told otherwise. And yippee, no denominator needing to be rationalized.